Hello, hello. Got the sound on today. That's a good start for me. Welcome, and we'll just start in a moment. I'm just going to check that it's live and the sound is coming out. And we're going to carry on with the summer 2024 paper. Hello, hello. Yeah, that's working. Good. Right. Okay, welcome back, everybody. Good to see you. And yeah, we're going to carry on just where we left off, which was looking at a summer 2024 paper, theory paper. We're just going to carry on where we left off. So I've said that too many times. Let's go. Let's just have a look then. So we had just finished in the last live stream. We'd just been doing some denary to hexadecimal, and we finished there. So next question then is question 3 on this paper, and it is the binary number 1010011 is stored in random access memory RAM. A logical left shift of 3 places is performed on the binary number. Give the 8-bit binary number that will be stored after the shift has taken place. So as ever, I want you to try these questions rather than just me doing them and you watching. So I'm just going to sit here quietly and give you a minute to try this. Remember, it is shifting left 3 places. As ever, you might need a pen and paper and possibly a calculator, depending on some of the questions coming up. But obviously, you'll not have a calculator in the exam, but for now, when we're doing this, it's fine. Okay, so some good answers in the chat, which are correct. So let's just go through that though. Let's have a look and see what is going on here. So we have got the binary 1010011. Now, if we're left shifting, we're going this way. And I infamously, with my husband especially, he's always telling me I get my left and my right mixed up all the time, but I write it down left. When we're doing a shifting like this, all we're doing is we're moving for every shift, and this time we've got to do it 3 to the left. We're just moving every 1 to the left. So if we do 1 shift, effectively, this way, these ones are going to get shifted 1 place. And you'll see, obviously, we're going to lose this 1. So effectively, and we add a 0 on this side. So we've got 1 and 1, and then we've got 3 zeros, and then we've got the 1 here, and then we've got the 0, but we lose this 1 here. So that's 1. We do it again. So we're going to shift another, we can forget about that one, another 1 place to the left. So that is a 0 and a 0, then a 1 and a 1, and then these 3, and then the 1 on the end, and we lose that 0. And then the last shift is 0, 0, 0, and then 1, 1, because those two get shifted here and here. And then we've got 3 zeros, but we lose that 1 there. And that's what, it doesn't matter if they ask you to do left or right, then yeah, it doesn't matter. That's what you end up with. And the answer is this here, 0, 0, 0, 1, 1, 0, 0, 0. Left is the one where your hand makes a correct L shape. That is right. Yeah, I just think, well, I'm right-handed. Which one do I write with a pen? That's the way I remember, but obviously that's not going to help for everybody, especially if you're left-handed. But yeah, that's a good way of remembering. Okay, next question then. Tick 1 box to show which statement about a logical left shift of 2 places is correct. Would it divide the number by 2, divide the binary number by 2, multiply the binary number by 2, divide the binary number by 4 or multiply it by 4. Which is the correct answer? Anybody in the chat want to tell me which one I think's right? So remember that it's 2 places. We're left shifting 2 places. Yeah, Josh is correct. It is D. It's going to multiply the number by 4. Let's see why that is. Okay. So if we've got our number and we just, I'm going to draw the column headers in binary. Let's have a think. Say, for example, we've got the number 1 here. Okay. So we've just got a number 1 there. We're going to logically left shift 2 places. So we're going to move that 1 2 places. So we put that here. What is that number? Well, 1 times 2 is 2. 2 times 2 is 4. So it has multiplied it by 4. So it's multiplied the number by 4. It started off with 1, now it's 4. So you can do this in the exam. If you're not sure, draw out the columns and think, hang on a minute, what happens if I'm going 2 places? Start with the number 1. Start with the number 1. It's nice and easy because you're starting with 1. How many is it going to times it by? And then, you know, they might say, what happens if you do it the other way? Well, it's always divide. So anyway, this way you are multiplying if you're going left. And this way you are dividing or multiplying by 2 and dividing by 2 if you're going the right hand side. Okay. Okay, next question then. We have got 101,00011 can be stored as 2's complement integer. And this is important. I know I've said it before in other ones, but other streams and in the lessons, that if they want you to know about, or if the binary number is 2's complement, they will tell you that that number is 2's complement. And if it is, if they don't mention it, assume that it's not. So if you shift it 4 times, it will be times 16. Yeah, it would be, yeah. So we're going to convert the 2's complement integer into denary. Show all your working. So remember that this is a 2's complement number, therefore it's going to be negative. And therefore the 128 is actually going to be minus 128. Yeah, that's correct. Yeah, good. So again, let's have a go at this. If you're a bit stuck, don't worry. This is what these sessions are for. So we've got 1, 0. Actually, what I'll do is I'll draw out the headers first. Because it's 2's complement, the most significant bit, which is the most left-hand bit, is always a negative number. And then we just draw in the other headers. We put our number into those columns. So it's 1, 0, 1, 0, 0, 0, 1, 1. And then all we do is we just add up the numbers. So it's minus 128 plus 32 plus 2 plus 1. And do try and practice this without a calculator, because you obviously don't have the use of a calculator. But minus 128 minus 32, sorry, plus 32 plus 2 plus 1 is minus 93. Okay, good. Yeah, so someone says you did 2 15-mark questions. Your first one was 6 out of 15. Then you did a second one, got 12 out of 15. Yeah, that's the thing. You just need to keep practicing. And that's really good, yeah. All right, let's question then. The binary number is measured as a byte because it has 8 bits. State how many bytes are in a kibibyte. How many bytes are in a kibibyte? Yeah, and a couple of you already got that right. It is 1024. Remember, let's just think about those. This is typical sort of question that they might ask. We've got 1 byte is 8 bits. And then if we've got a kibibyte, then that is 1024 bytes. And then if we've got a gibibyte, then that is 1024 kibibytes, etc. So basically, every time you go up, maybe, get it right, maybe, then Gibby, that's 1024 maybe, etc. Good. Okay, next question then. Data packets are transmitted across a network from one computer to another computer. Describe the structure of a data packet. So there's only 3 marks here. You don't have to write an essay. You just need to state effectively what the 3 parts are. Can you remember? Yeah, good. So look, correct answers again. It is the header, the payload, and the trailer. So try and use the word trailer, they prefer that. So if we have a look at that, I'll just draw it out. 3 parts to the packet. This is really important for cybersecurity. If you're going into cybersecurity or you're thinking about it, knowing about data packets is a really important part of it. And we've got our header there. And also in our header, we've got things like the IP address of the sender. We've got the IP address of the receiver. We've also got the packet number. There's something else and I can't remember what it is. Anyway, payload is the actual data that we're sending, and the trailer, it basically has an end of packet sort of indicator. And also it has the checksum. And we won't go into checksum now, but it will come up, I'm sure, very shortly because they love asking about it. Okay, that's data packets. Let's look at the next question. Packet switching is used to transmit the data packets across the network. Identify the device that controls which path is taken by each data packet. You've probably got one in your home. So the answer to part B is it's a router. So it's a router that transmits data packets across the network. That's the device. And then part C, serial data transmission is used to transmit the data packets across the network. Let me just quickly show you the answer to this, because I have got the answers here. There we go. And it is, there we go, the router. So last question on this section. Serial data transmission is used to transmit the data packets across the network. Explain why serial data transmission is used to transmit the data packets. 3 things we need to say about this. Basically, why do we use serial? That's what it's asking. Yeah, so someone said because serial can go for long distances, that's correct. It's cheap. So I would say, why is that? Why is it cheap? Always explain why that is. Basically, because it's using one wire instead of many. And it's less likely to get interfered with. Yes, so that is correct. The cheap one is not in the mark scheme. So if we have a look at the possible answers for this, yeah, that's right. Yeah, so someone said, for these questions, you just have to look at the marks and write that many points. That's exactly it. Yeah. You don't have to write an essay. It's cheap because it only needs a single wire. Yeah, that is correct. Now, that isn't, the fact that it's cheap isn't in this mark scheme. So they've got the network may be spread over long distance, so it's more reliable. Bits will be sent or arrived in sequences, so bits are less likely to be skewed. Less crosstalk or interference, so less likely to have errors. The data may not need to be transmitted at a fast speed. The cables in the network only use serial transmission. So just a couple of points about this. So this bit here, this point here, it says the network may be spread over a long distance, so it's more reliable. Those dots basically mean that in order to get the second point, you must have put the first point because they continue on. We've got dot, 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 and then dot, dot, dot there. However, with this one here, you don't have to get the previous point in order to get this one underneath because there's no dot, dot, dot on this one. There's no dot, dot, dot on this one, so you don't have to have put that in order to get this one. So you would not get a mark for saying it's cheap. It's not in the mark scheme, so probably not, no. Really all they're talking about, or what exactly was the question again? It was yeah, I don't know. So it's not in the mark scheme. I can't guarantee that they give you a mark. which is a bit annoying because, you know, I don't see why you shouldn't get a mark for that. But yeah, I'm not sure if they'll give you up. This sort of question comes up again and again, though. They really do hammer home with this question. Okay, let's look at the next one. A computer uses both random access memory and secondary storage. State the purpose of secondary storage. And then you might as well do B as well. So if you do B, circle 3 examples of optical storage. So do A and B. Yeah, so state the purpose of secondary storage, and it is to store data or files permanently. And that word permanently is kind of like the buzzword if they do ask you about why we have it. And then the 3 examples of optical storage is a compact disc, CD, a DVD, and a Blu-ray disc. So it's compact disc, DVD, and Blu-ray. There you go. Okay, so next question is explain why a computer needs RAM. RAM, random access memory, 3 marks. So 3 things about why a computer needs RAM. Yeah, so someone said chapter 3 hardware in the textbook is twice as long as the average chapter. Yeah, I know the reason for that, and that's a hang off from the previous syllabus. And the new syllabus, when they released it, it wasn't clear how much detail you needed to put in the exam. The syllabus was vague about how much detail you needed to put about how the hardware worked. So the old syllabus had a lot of detail about how a CD-ROM works, about how a hard disk works, etc. But and how input and output devices work as well. So keyboards and screens, etc. And they've just kind of dropped most of that. They just kind of say, yeah, there's input and output devices and other ones, and just tell us very, very generally how they work. So that's why. Computer needs RAM to store data in an accessible place for the CPU to reach quickly. It needs RAM to run applications that are currently running. Not sure about the third one. Yeah, so it needs, so you, yeah, so you're kind of there actually. Yeah, let's have a look at the answer, because then you can see rather than hear me. So it stores data temporarily, stores data currently in use. To store software currently in use, data can be accessed faster than secondary storage, and to speed up the fetch stage of the fetch execute cycle. So don't worry if you haven't got that last one, because guess what's going to be in your lesson this week? For those of you who are my live students, we're doing von Neumann this week. It's the last thing. So yeah, don't worry about that. Yeah. So you've got, computer needs RAM to store data. Yeah, they probably would give you a mark for the first sentence. It needs RAM to run applications that are currently running. Yeah. So you should get 2 out of 3 for that. If a word's in bold, by the way, I don't know if I've said that before. I think I might have done. If a word's in bold, it means that's their preferred term. It doesn't mean you have to say it. If they're after an exact term, it would be underlined and in bold. Okay, let's look at the next question then. Now, yeah, actually the next question is about the fetch, decode, execute cycle. And who has done von Neumann? Who studied that yet? So those of you who are my live students, you won't have done this yet, but we're doing it this week. How many of you done this? How many of you done the fetch, execute cycle? Okay. So we might skip this one and come back to it another time. There's plenty of other questions about von Neumann and the fetch, decode, execute cycle. So I'm not going to go into it today. Yeah, we're learning it tomorrow, basically. Okay, you've learned it in a textbook, not since last year. All right, so I think we'll leave this question because most of you haven't done this. And there is other exam papers where they do ask about it again. So we'll leave it. But it is important. It's basically, how does the CPU, the RAM, and well, mainly the CPU and the RAM, but also sometimes the hard disk, how do they execute code, basically? How do they run instructions? And it's a very sort of formulaic way it does it. And it's still very important today, because even the sort of the ways that they've brought in some of the AI technology, they have processes that kind of work differently to this. And that's one of the things that they're always going on about, is it's not like fetch, decode, execute. Anyway, we'll come back to that one. So let's look at the next one. It says a computer needs firmware and system software to operate. State the purpose of firmware. Give one example of firmware and give 2 examples of system software. Okay, so I'm going to go through the answers. So what is firmware? Well, it's a number of different things depending on what the computing device has. But basically, it permanently stores instructions. So this can be in an embedded system. So if it's got permanently stored instructions, then it could be, for example, a vending machine. And in the firmware, effectively the ROM of that vending machine is the instructions to run the vending machine. So rather than have a sort of computer system like we've got with our laptops or our desktops, whatever computer you're using now, then it is very different because it's embedded. But the whole point of them, if it's in a computer like ours that we're using now, would be to store instructions when you first start the computer. And a lot of the time it will just sort of say to the computer where the operating system is, and the operating system will then take over. So it provides the operating system with a platform to run on as well, controls, and that obviously that in embedded systems, that's more for embedded systems. So the third one provides operating system with a platform to run on, controls and manages or allows communication with hardware, stores instructions securely to stop them being easily corrupted. So other than if we've got, for part B, it says give one example of firmware. Well, operating system in an embedded system, programs in an embedded system. But if it's a computer like ours, bootstrap, bootloader, BIOS, that's what they're used for. And then last one, give 2 examples of system software. So system software is basically the operating system and any utility software. If you gave 2 examples of utility software, then that can be awarded, it says there. So I don't know, there's so many utility software. Firewall, I don't know, defragmenter, I don't know, all sorts of stuff that you can list. Next question. Oh, fill in the gaps. Data is encrypted to keep it safe during transmission. Complete the paragraph about asymmetric encryption. Use the terms from the list. Some of the terms will not be used. You should use a term once. So it's asymmetric encryption. And yeah, so good example there. So the first one is plain text is, this one here, plain text is encrypted into ciphertext using a public key. The encrypted data is then transmitted from the sender to the receiver. The encrypted data is decrypted using a private key. So let's just go over that just very quickly. Let's go over that, what happens there. So when you use a website with the padlock, or it says HTTPS on it, that's using asymmetric encryption. And what happens is your browser requests data from, or requests the website to the web server. And the web server sort of says, give me your web pages HTML. The web server then sends back its public key and says, well, actually, before I do that, you have to have this public key. And if you want to send me anything, then you have to use that public key and encrypt it. So your browser then checks it also sends the certificate. Now, obviously, that wasn't in that question, but I'm just covering it anyway. So the certificate is basically, if you've got HTTPS, then you get a certificate and you just buy it once a year from one of hopefully legitimate companies. And your browser then checks that certificate and says, yes, it's valid or it's not. And then from then on, whatever you send encrypted using the public key. So it sends some data to the web server, and in the web server is the private key. And obviously they need to keep it safe so it's not hacked. If it is hacked, I'll have to release another key set, basically, a new private and public key. And anything that it gets is decrypted using that private key. And the public key can go to anybody, including hackers, because it's literally given to anybody who wants to communicate with you. And it's used not just over browsers, but it can be used on email as well and things like that. Okay, next question. How are we doing for time? Yeah, we've got enough time for another one. Right, so a farmer uses an automated robot to plant seeds in the field. State what is meant by the robot being automated. And then give 3 characteristics of a robot. Yeah, good. Yeah, so it operates without human interference, or they've got actually in the mark scheme, they've got without human intervention, but interference is fine. Yeah, that you still get a mark for that. Good. And then the 3 characteristics of a robot. So it's able to move, yeah, able to sense surroundings. Yeah, so that's, you'd get 2 out of 3 for that. Anybody else want to add anything for that? It is worth learning the characteristics because this question has come up quite a few times actually. So we've got, it has a mechanical structure, has electrical components, it's programmable, it can move. So a couple of you have said sensors. I can't see why they wouldn't give you a mark for that because that is an electrical component. So hopefully they would give you a mark for that. But do try and learn this bit here because, yeah, this is aware of its environment. Not necessarily, no. No, it's not necessarily aware of its environment. Mechanical structure, electrical components, programmable. I mean, the fact that it says it can move as well, that isn't in all of the mark schemes, but the other 3 are. Okay, we've just got enough time to finish the last bit. So it says the robot plants seeds and stops when it reaches a fence. It then turns and continues planting seeds. The robot uses sensors and a microprocessor to know when it reaches a fence. Explain how the robot uses sensors and a microprocessor to know it has reached a fence. And it's how many marks? 6 marks for this. So 6 things about how this would work. And this kind of goes back to the automated systems that we did in the live lessons not so long ago, where we've got a microprocessor and sensors. Obviously, because it does say that. Yeah, good. So that's a good answer there. Let's have a look. In fact, yeah, we need to have a look because we've run out of time. So basically it says, well, it says a proximity sensor, LiDAR. I don't know. They probably should. They should give you a mark for that because that's the latest technology. Proximity sensor is used. The sensor continually sends digitized data to the microprocessor. The microprocessor compares the data in a stored value or range of values. The value is written within the range or matches the robot, continues planting. If the value is above, below, outside the range, a signal is sent by the microprocessor to turn or stop the robot. Using an actuator to turn or stop the robot, this process repeats until the robot is turned off. So try and sort of, because there's 6 marks there, do sort of say what the sensor is. It's always sending data until it's switched off or told to stop. Microprocessor compares data. Just think of that if statement that's been written. And then what does it do with the if and the else? What happens? Well, it either turns or it carries on, etc. Okay, so we'll stop there. We'll carry on tomorrow. I'm back again tomorrow at 10 o'clock for Improve Your Python. We're going to be looking at if statements, and then back again at 6 o'clock tomorrow night for the next revision. Take care, and I'll see you tomorrow, hopefully.